Hello and welcome. In this tutorial, we'll be using PSIM to simulate a three-phase full-wave bridge rectifier. We'll start by looking at the output without a filter, and then we'll see how adding a filter capacitor smooths the DC output. Let's get started. Here we have our circuit already laid out. It consists of three AC voltage sources, a 6-diode bridge, and a resistive load. First, we need to configure our three-phase sources. For the first source, we'll set the peak amplitude to 200 volts and the frequency to 50 Hz. The phase angle will be 0 degrees. For the second source, the amplitude and frequency are the same, but we'll set the phase angle to 120 degrees. And for the third source, again, same amplitude and frequency with a phase angle of 240 degrees. This creates a balanced three-phase supply. Next, I'll add some voltage probes to our input lines so we can visualize the three-phase waveforms. We'll label them R, Y, and B. We also need a probe across our load resistor to measure the output voltage. Let's call this Vout. Our load resistor is set to 100 ohms. For our first simulation, we will run the circuit without any filter. Let's run the simulation. A graph window will pop up. First, let's add our input voltages, R, Y, and B, to the display. As you can see, we have three perfect sinusoidal waveforms, each 120 degrees out of phase with the others. This is our AC input. Now let's add our output voltage, Vout, to a new graph. And there it is. This pulsating waveform is the rectified DC output. The bridge rectifier has converted the AC input into DC, but you can see a significant amount of ripple. This is the output without any filtering. Now let's see how we can smooth this out. We'll go back to our circuit and add a capacitor in parallel with our load resistor. This capacitor will act as a filter. I'll place it here, and let's set its value to 1,000 microfarads. Let's run the simulation again. Look at the output voltage now. The capacitor charges up and then slowly discharges into the load, which significantly reduces the ripple. The output is much smoother than before, though a small ripple is still visible. What happens if we change the capacitor value? Let's see the effect of a much larger capacitor. I'll change the value to 5,000 microfarads. Now, when we run the simulation, the output is almost a perfectly flat DC line. The larger capacitor does a much better job of filtering out the ripple, giving us a very smooth DC output. So to summarize, we've seen how a three-phase bridge rectifier converts AC to DC, and how a filter capacitor can be used to smooth the output voltage. Thanks for watching.